This is the installation of a 12-foot tall, 400-foot long AquaDam installed in Alcova, Wyoming. This AquaDam has ropes underneath it going down, out, around the roll, and back to shore. These are restraint ropes. They're tied back to the excavator tracks right there. And that's used to restrain the roll from unrolling while the dam is filling. The corners of the dam are tied off to a piece of equipment on each side. Now, the two 6-inch submersible hydraulic pumps are being lowered into the water, and they run these two 8-inch hoses, 600 feet long, I think, down around and into the two fill tubes of the AquaDam. So the idea is we want to start here, and we want to take the dam on a path that ends over on the shore over there so we can isolate this work area for dewatering. There will also be a 2-foot tall dam installed at the top of the spillway behind the gates. Okay, here's a trout, could be a rainbow trout, maybe a brown trout that was coming up to the surface to eat some bugs in the work area pool. And very typical of the wildlife in this stream. This Sloan's River is known for the trout that it produces. Very famous. So in order to keep the water quality up for these fish, an AquaDam was used instead of a dirt cofferdam to isolate this work area. No turbidity. There's where we want to end the dam on the far shore. There's the bridge, there's a power plant, and a power yard right next to the work area. 12-foot dam going down the bank. You can see there's an 18-inch tall dam that goes underneath of it. That'll be filled up last, just a little bit, to improve the seal beneath the AquaDam. And the beginning open end of the dam is brought up on top of the bank, the starting bank. That's to provide enough elevation to get the main body of the AquaDam filled to its full height. There goes a crawdad, endemic to the region. Alright, now we're in the water, looking back at the people who aren't in the water, and of course the AquaDam, which is beginning to fill and unroll as it fills. The restraint ropes are present, but not being used. There's a contractor further out along the path of the dam. Now we're on top of the AquaDam as it's filling. It's only an inch or two above surrounding water level, but that's enough for it to stay in place and provide a relatively solid platform for people to walk on. Switching yard over there, and the hydropower plant building, the white boxy structure. And there's the shore we want to land on over there. The dam is about 2/3 of the way unrolled. We're getting ready to start a turn. We're pulling on the bottom seam with the forklift way over there. Then we need to bring some equipment down on the far side, on the far bank, and pull on a rope that's wound around the end of the log that's on the outside of the turn to be made. And that'll help the dam unroll and be redirected or reoriented in the direction that we want it to be, to abut the bank at a good angle, a perpendicular angle. As you'll find out, it didn't quite happen that way. The bank wasn't appropriate for the dam, so as the dam came up to it, the dam shifted in order to sit properly against the bank with which it was presented. No problem, but it just didn't turn out how the drawing showed. But it worked to isolate the work area. An initial pull has been made, an initial turn. We've got the loader hooked up, rope to the outside of the dam, and just an overview shot shows everything. Now we've got it pretty close to the embankment. We've got a gut rope that goes around the AquaDam, right where I'm pointing, and then we tie those restraint ropes off to the gut rope so the dam holds itself in place. Then we continued to fill it. Because of pumping difficulties, we weren't able to get a full day of pumping into this dam, only about a half day on the first day. So we had to leave the dam in a partially filled state overnight, downstream of a hydropower plant. Not knowing what the water levels were going to do overnight, we packed as much water into the AquaDam as we could, about a foot of head in the dam, before the end of the work period, so that overnight the dam had as much chance as possible to stay in place, to stay higher than the surrounding water levels. And it worked out great. So there's the bank over there. It doesn't quite match up with how the AquaDam needs to marry up to the bank. So instead of changing the bank, we let the dam adapt itself to the existing ground conditions. And did it that way. Alright, those restraint ropes are tied back to the gut rope there. Overview shot. The dam gets wider, or is wider, where it's shallower, and narrows up where it's deeper. Just past the first turn there is the deepest point. Also the narrowest point for the AquaDam. This is the end of day one. We've filled the AquaDam up as much as we can before the end of the work period, tied it back so there's communication between the work area and the rest of the river. And now we're going to go home and come back tomorrow. Alright, come back the next day. There's some scum on the water. This is showing the area at the end of the AquaDam roll, between the roll and the far bank. And so you can see there's a little bit of flow going one way, then the other way. Then they get those 6-inch pumps turned on, and it starts the flow going into the work area, without a doubt. We wanted to get as much water into the dam as we could before we isolated the work area. The reason for this is because the work area, once it's isolated and you continue to pump from it, will go down in height. The river will stay the same height, so the water levels on either side of the AquaDam are going to not be equal, and that is a hydraulic differential, which imparts a force across the AquaDam. The AquaDam's not ready for that force until it's full, or nearly full. So to get away from that, we pumped as much water into the dam as we could before we reached the far bank with the AquaDam. A little hot spring. Okay, so here's the 6-inch pumps the next morning. Every time these pumps turned on and turned off, the hose would shift and fall down into the water. Enough slack eventually accumulated that the hoses became kinked off and the flow rates were reduced significantly. So that was a challenge on this job, not turning the pumps off and on as much and trying to reduce that eventuality. There we've got the restraint ropes tied to shackles on the gut rope, and then 3 more ropes tied to those shackles back to a bulldozer on shore. So we'll continue adding water to this dam, cut the ropes, let it unroll in a straight line, or that was the plan, and then continue filling. But what happened was, when we cut the ropes, the dam unrolled, and then as it adjusted itself to the underlying ground topography, it shifted to the left. But no problem. So once that shifting was done and the dam had settled, then we continued adjusting the AquaDam, made a turn with it so that it climbed the bank properly, and continued filling. Now before we continued filling, we put an 8-foot tall AquaDam on the outside of the turn to give the 12-foot dam support. Okay, cutting the restraint ropes, or cutting the loops on the gut rope so that the restraint ropes all the way back to shore engage. This is to maximize our holding power. Instead of everything depending on the 1 half-inch gut rope, now by the end of this we'll have 3 half-inch ropes taking up the force of the AquaDam wanting to unroll. And as we cut the rope, there's some slack that has to be taken up, so the dam unrolls little by little and takes up that slack, and then it becomes restrained again. The angle of these ropes to the roll is kind of off. It worked, but it would be better if they were coming straight back from the roll. They weren't, it wasn't, but it worked out just fine. Just fine. So now the roll is being restrained by the ropes that are each tied back to the bulldozer back on shore. There's the gap to shore with the water clearly moving into the work area now. The loader is tied on to a rope that's wound up with the AquaDam. Pulling on that rope will help the dam unroll. This was to help the AquaDam unroll up the bank. Okay, so we've cut the ropes. It unrolled up the bank. Now we're going to hook on with a piece of equipment on each side of the log that the dam is rolled up on, and then pull to make the dam unroll all the way. We've got 2 pieces of equipment. We've got the ropes laid out. The ropes are wound around the end of the log on each side. Okay, here's where it's coming up the bank. We're going to put the 8-footer right there. So as the 12-footer fills, it doesn't want to keep creeping down that bank to the right. It will lean into the 8-footer that's going to take up that space. And that worked out really good. Worked out well and exactly how we anticipated. Overview, we've got the AquaDam unrolled now. We've got the 8-foot dam in the water and it's filling. Despite its short length and small height, the 8-foot dam took a long time to fill. I think there was some internal kinks in the hoses inside the AquaDam. We used 2 3-inch pumps and it took 6 hours to fill. In the interest of saving time, once the 8-foot dam was filled to a point about a foot higher than surrounding water level, we began adding water again to the 12-footer to bring it up to its full height as well. Now we've got water in the tail end of that 12-footer up on dry ground. No problem. It's continuing to fill. The end of the 12-footer is tied off to the loader. The 8-footer is tied off to the forklift, or vice versa. But the important thing is supporting the AquaDam during installation. Okay, about 40 minutes later, the AquaDam continues to fill. It's about a foot or two taller than it was. The loader and the forklift are both tied off to the 8 and 12-foot AquaDams, respectively. This is to support the material while it's filling with water. Once the dam is full, that support will no longer be needed. Here's a view from the starting bank looking down. We've got the equipment tied on, is what I'm pointing to. At this point, we're also starting to measure the height of the dam as it fills. So this is about another hour or two later. The end of the dam is about 4 foot higher than the ground that it's on top of. The dam is nearly filled, if not totally filled. And we've got the 8-foot tall AquaDam tied off to the end seam of the 12-foot tall AquaDam. This is in case the water levels outside the work area spike from the hydro plant. The 8-foot dam might want to float, so we've got the 8-footer tied off so it can't float away. It has to float in place and stay in place as the water levels go up and go down. The 12-foot AquaDam continues to fill. It's about 5 feet tall on the high ground, probably close to 10 feet tall in the middle. There's the hot spring, there's the 8-foot dam next to it. And the work area is dropping now because we've isolated the work area. So the pumps are drawing only from the water that's in the work area, not the rest of the river. So now we're inducing a hydraulic differential across the width of the AquaDam. But it wasn't much. The surface area of the work area was huge. So it only dropped about 6 inches before the AquaDam was actually filled. Okay, here's a close-up of the hydropower plant discharge canal that runs into the same main channel as the river. And if they release a lot of water for more power, that water level is going to rise. So that's why we've got the 8-foot dam there tied off. So if it does rise and the dam becomes buoyant, it's just going to stay in place. And then when the water level goes down, the same thing. It'll just stay in place. Now we're at the top of the Alcova Dam, looking down at the whole thing. Looks great. The dam continues to fill. Oh, now the dam is done filling, and the water is being discharged from the work area itself. So there is the discharge of those 2 pumps is running in behind the turbidity curtain outside the work area. So now the AquaDam is full. It's 12 feet tall at the lowest point along its path, and the work area is being dewatered. This is after another 4 or 5 hours of pumping. The work area is clearly dewatering. There's a 2 or 3 foot drop in the work area water level, and the only place where water's touching the AquaDam now is in the lowest point along the path of the dam. That's where the deepest water is. That's where the AquaDam attains its full height. Good looking installation. Took about 2 days from the time the dam showed up on site until it was fully installed. Very windy in this area, and there were mini geese flying up and over the Alcova Dam, and the wind would blow them off course, so I got some video of that too. Very windy. And there's the Alcova Reservoir proper. Okay, back to the work area. The water level continues to drop. There's some ground that's been exposed, high ground. And before the AquaDam was installed, that high ground was only noticeable by the lower depth of water in that area. Now we can see it as high ground, but before it was shallower water. The boat has become beached. Here's a close-up of the seepage coming out from beneath the beginning of the AquaDam at the bottom of the starting bank. They cleared the rocks on the bank, but they didn't clear the rocks that were in the water, even though I asked them to. They decided to take the hit with the increased seepage and just keep up with it with a pump, and they did. And there was increased seepage, here it is, and they did with a bigger pump, no problem. So that was the idea. But the real thing would have been, let's pick those rocks out, and then we don't have to get more pumps. But that wasn't in the cards. That's how the contractor wanted to do it, and so that's what we did. As the work area dewaters, the hydraulic differential between the work area and the river will increase. That differential is what forces water beneath the dam into the work area. So the greater the differential, the greater effective seepage flow you're going to see. No one knows what the seepage will be until the work area is dewatered, and then you can see. But until then, it's just a guess. There's the discharges of the two pumps running in the work area into the... Let's see, they're discharging onto a mat and then splashing down into an area contained behind a turbidity curtain. Back up on the hill again, dewatering continues. Not much to say. The dam was filled after about 4 or 5 hours of work that day. And then it's all pump time in the work area after that. From outside the work area looking in, the AquaDam's about 4 or 5 feet taller than the surrounding water. There we go. Now we're looking in behind the AquaDam. You can see it conforms to the uneven ground conditions on the bottom, but the top of the dam is pretty much level with itself. On the far bank with the blue truck is a very popular fishing spot. People come in and fish just downstream of the spillway, downstream of the hydro plant, and that seems to be a nice place to catch fish. Work area has dewatered another foot or two, exposing some gnarly rock there to the right. Very good we didn't go over that rock. That would have really affected the seepage. But we stayed away from there, stayed away from the work area, got onto pretty good soil. And what we ended up with was tolerable seepage, acceptable seepage. No one had any problems with the amount of water coming into the work area. Another glamour shot of the AquaDam and the Spillway and Alcova Dam. Okay, continued dewatering. We're coming back into the seepage area here at the base of the beginning of the AquaDam. This is all that there is in this area. It's all concentrated into this little channel, and then it flows down into the work area proper. We've got some fishermen on the banks trying to catch some fish because they're all being concentrated as the water is being drawn away. The fish are all concentrating into the remaining water. So good odds, but not for these people. They didn't catch anything while I was there. Okay, here's a close-up of a rock that's typical of the area. It would have been better to remove this rock, but going over it is no problem, apparently. It's rounded, it's not sharp, and the AquaDam seems to be accepting the interface with the rock suitably. No problem. No tearing, no damage to the AquaDam. Unlike if this was a straight up and down rock with a knife-like edge to it, would have been a different story. So here's the seepage coming out of the far, or under the far end of the AquaDam. Very minimal. Very minimal. Didn't have that big rough rock like at the beginning. So we got a lot better seal. This is definitely the low spot. Even after the work area has been drawn down so much, this area here is another 18 inches lower. So that's where the dam has to be 12 feet tall. That's the maximum depth that the AquaDam needs to control. It's all right there. The lowest point dictates everything. And look at all this stony stone. Minimal seepage. Here we go. We're into the beginning of the dam again. And the water's finding its way from the river, under the dam, through the rocks, and into the work area. There you can see some flow beneath the AquaDam. Now this may be water flowing out of the AquaDam from damage, but I don't believe it is. After a month of being installed, the dam shows no sign of water loss. There it is as it climbs the bank and goes to the far bank. Now we can walk across this channel. It's not a problem. Here's some of the stony stone I was talking about earlier. We really never want to go over this type of rock. It'll just be a loser every time between damage to the dam and, more importantly, seepage under the dam into the work area. Going out there, not only is it smoother, but it's also higher ground, so a shorter AquaDam could be used. 12 foot instead of a 16 foot tall AquaDam. Power plant, 8-foot dam, 12-foot dam, spillway, work area, and work area dewatering pump discharges. These pumps started getting clogged up and the flow rate decreased over time. But still moving water. A little hump of land showed up in the low spot It's the high spot of the low spot. So as the water continues to draw down, we're just going to see more and more of the underlying topography. As the work area draws down, it leaves water lines on the dam. That's what we're seeing here against the side of the dam, are horizontal water lines. Alright, this is near the end of day 3. Work area continues to be pumped down, but there's a lot of water to move. So it's a long-term kind of thing. A couple weeks later, we've got the work area almost completely dewatered. The contractor's got a big berm of sand behind the AquaDam, which is a great thing because, as you can see, the water level spiked tremendously against the side of that 12-footer. And we think that without the sand berm, the 12-footer would not have stayed in place. So good job on the contractor following the instructions, get the support behind the AquaDam. Really made a difference. The water levels are way up. Way up. It's evident now that the work area has been dewatered that water's actually coming out from behind the concrete spillway. This isn't water coming from under the dam. This is water coming from somewhere else into the work area, from behind the spillway wall. Looking down over the dam, reservoir, the spillway, the gates, the work area, and the AquaDam. Looks great. Work area is totally dewatered. The work is commencing on the spillway. They're blasting the concrete with a high pressure water hose, and then that blasts the concrete away from the aggregate and the reinforcement bars that are inside. It allows them to resurface the spillway without needing to re-pour the whole thing. Seepage has been controlled with a single, looks like 6-inch pump down behind the turbidity barrier blocks. This flow on the right is indicative of the seepage flow. Going into the work area is what's coming out of the work area. And they're keeping the work area in here dewatered. Alright, well thank you very much for sticking with me through this whole video. It was a pleasure to put this AquaDam in. It was a pleasure to narrate. And I hope that this will help in the future. Alcova Dam, Alcova, Wyoming, Sloan's River, 2020.